Dear children, welcome to chapter Number Systems session 4. In this video, we will learn how to visualize the given real number on number line by successive magnification. Then to locate the real numbers on number line geometrically, and then we have to learn some laws of exponents for real numbers, then rationalize the denominators of the given real numbers. Now look into this question. Visualize the representation of 2.667 on number line by successive magnification. Do you know the meaning of successive magnification? Successive means continuous. Magnification means enlarging or zooming the number line. The given number is 2.667. How we are going to represent this number line? Before you start, you will need pencil and scale. First, be ready with your pencil and scale. Right? Now, once again, read the number 2.667 or 2 point something. Right? This is one number. After the decimal point, how many digits are here? Yes, there are 3 digits. So, we require 3 number lines. First, draw 3 number lines using scale and pencil. Draw 3 number lines. In each number line, mark 2 points and the length of these 2 points is take as a 10 centimeter. So, now 2 point something, it's a number. It lies between two natural numbers. What are they? It is more than 2. 2 point something means it is more than 2 and less than what? 3. So, now divide this into equal 10 parts. Divide this into equal 10 parts. So, take each part as 1 centimeter because we took as a 10 centimeter length. So, each part is 1 centimeter. Okay. Now, the point value is 2.1. This is 2.2, 2.3. This is 2.4, 2.5, 2.6, 2.7, 2.8. This is 2.9, right? Now, again read the number. 2.6 something. Read in this way. 2.6 something is a number lies between what? 2.6 something lies between. It lies between 2.66 and 2.7. Right? So, it lies between 2.66 and 6 and 2.7. So, now I will take this as the number should lies in between 2.6 and 2.7. So, I will keep a lens, magnifying lens here. The number, I can guess the number lies in between 2.6 and 2.7. So, using the magnifying lens, zoom out this number 2.6 and 2.7. Again, and this is 2.7, and do the same procedure as before. Divide this into equal 10 parts. Equal 10 parts. Now, what's the first point? This is 2.61. This is 2.62. This is 2.63, 2.64, 2.65. This is 2.66, 2.67, 2.68. This is 2.69. Again, look into the number. Now this is 2.66 something. So 2.66 something is in between 2.66 and 2.67, right? Where is the number 2.66 and 2.67? See, this is in between these 2 points. So again, keep your zooming lens or magnifying lens here. I will keep the magnifying lens in between these 2 points. Okay. Now these 2 points are what? Again you have to zoom out the number. Zoom out this. This is 2.66 and this is what? 2.67. Ten parts. Okay, now what is this? This point is 2.661. This is, I will write here, 2.662. And this is 2.663. This is 2.664. 2.665. This is 2.667. 666. Not 667. 2.666. Okay. This is 2.667. This is 2.668. 2.669. Okay. Now where is the number? The given number 2.667 is in our number line. Locate that point. The number is here. We get the number. The number is this, right? In this way we will locate or represent the given number on number line, and the method is known as successive magnification. Now you can write the boundary also using the scale. Write down in this way. Here also 2 point, this is 2 point, magnifying the 2 boundaries in this way, right? Did you get this? Yes. Second question, visualize 4.262626 on and on number line up to 4 decimal places using successive magnification. Again, what is the given number? The number is 4.26 on and on, 262626, like that. So we have to visualize this number on number line up to 4 decimals. So after the decimal point we need how many digits? 4 digits. So we can write in this way, 4.262626 on and on. In this way, 2626. Right? Now you can easily know how many number lines should we draw. We need 4 number lines because after the decimals there are 4 digits, so we require 4 number lines. Draw 4 number lines using scale. 4 number lines. Yes. Again, locate the 2 points. These 2 points are separated by a distance 10 centimeters. Now You can see 4 point something. This is 4 point something. So it is more than 4 and 4 and 5. Write down 4 and 5. Now what we have to do? Divide this number line into equal 10 parts. Equal 10 parts in this way. Now write down, this is 4.1, second point is 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9 in this way. Again see the number 4.2 something. So this 4.2 something should lies in between what? It is more than 4.2, right? So more than 4.2, so less than what? 4.3. So we have to zoom out these 2 points, 4.2 and 4.3. So keep the magnifying lens here, right? 4.2 and 4.3. Keep the magnifying lens here. Okay. This is magnifying lens. Therefore, this is what? This point is 4.2. Note down, this is 4.2. And what is this? 4.2. Okay. Point, this is 4.3. Again divide this into equal 10 parts. Here also divide it into equal 10 parts. So what is this point? This is 4.21, 4.22, 4.23. This is 4.24, 4.25, 4.26, 4.27, 4.28. This is 4.29. Right. Now again look into the number. It is 4.2 something, 4.26 something, 4.26 something should lie in between what? 4 point, it is more than 4.26, more than 4.26 and less than 4.27. So keep your magnifying lens in these 2 points, right? 4 point in between 2 points, 4.26 and 4.27. Again, this is the magnifying lens. Now what are the 2 boundaries? This is 4.26 and this is 4.27. Write down 4.26. This is what? 4.27. So divide this into equal 10 parts. Now this is what? First point is 4.261. This is 4.262, 4.263, 4.264, 4.265, 4.266, 4.267, 4.268. This is 4.269. Again look into the number. This is 4.2 4.262 something. What is this? 4.262 something. So 262 something is more than 262. 4.262. Where is 4.262? Yes, this is here. So more than 4.262 and less than what? 4.263. So keep your magnifying lens in these 2 points, right? Yes. Four point 262 and 4.263. This is magnifying lens. So what is the two borders? This is 4.262 and this is what? 262. 4.262 and what is this point? 4.263. Again divide this into equal how many parts? Yes, 10 parts. Each part of length 1 centimeter. This is what? This is 4.2621. This is 4.2622. This is 4.2623. 4.2624. 4.2625. 4.2626. This is 4.2627. 4.2628. This is 4.2629. In this way. Now we can identify the given number on the fourth number line, 4.2626. Definitely the point is here. 4.2626 is here. So mark that point. This is 4.2626. In this way we will locate or we can locate any given rational numbers or real numbers on number line using successive magnification. Now let us see operations on real numbers. The sum or difference of a rational number and an irrational number is irrational. Now verify this rule by taking an example. For example, take one rational number 2 and an irrational number square root of 2. Now their sum, what is the sum? 2 plus root 2. Yes, 2 plus root 2 we can't simplify further. So 2 plus root 2 is an irrational number. Therefore, we can conclude that the sum of a rational and an irrational number is always irrational number. Right? Similarly, their difference. I will take the same example. 2 is a rational number. Square root of 2 is an irrational. So 2 minus root 2 is an irrational number. Therefore, here also we concluded the difference of a rational and an irrational number is always an irrational number. Now take down this. Yes. Next, number 2, one more rule. The product or quotient of a non-zero rational number with an irrational number is always irrational. Let us see, taking by one example, product of a non-zero rational number with an irrational number. Take same example. 2 is a rational number, square root of 2 is an irrational number. 2 and square root of 2, their product means what? 2 into root 2 is equal to what? Simplify 2 square root of 2. Yes, we can't further simplify. So 2 root 2 is a irrational number, right? Similarly, take their quotient. Quotient means division. 2 rational number divided by an irrational number root 2 is equal to what? We can write 2 as square root of 2 into square root of 2 divided by root 2. Keep as it is. We can write 2 as root 2 into root 2, because the square root of 2 into square root of 2 is equal to square root of 4. Square root of 4 to root 2 into root 2. So root 2 cancelled. So answer is what? Product division. Quotient is what? Root 2. Again this is what? It is an irrational number. Similarly, therefore we can conclude that the product or quotient of a rational number with an irrational number is always irrational. Did you get this? Yes, take down. Now let us see third rule. What is this? If we add or subtract or multiply or divide two irrational numbers, then the result may be rational or irrational. It may be rational or it may be irrational, right? Now let us see one by one. Take two irrational numbers and their sum. What happens if we add? I will take two examples. Take two examples. Two rational numbers. I will take root 2, one example, and one more number is root 3. Now these two are irrational numbers. Now I will add them. Now root 2 plus root 3 is equal to what? We can't simplify. So the answer is root 2 plus root 3. Now what is this? This is an irrational number. So if we add two irrational numbers, then the or we take one more example. I will take in this way. Let root 2 minus square root of 2 is one irrational number, and take one more irrational number plus root 2. Now their sum is equal to what? Minus square root of 2 plus square root of 2 gets cancelled is equal to what? This is 0. Now what's about 0? 0 is a rational or irrational number? Yes, it is a rational number. So we can conclude that if we add two irrational numbers, then the result may be irrational. Here this is the result is irrational, and in second case the result is rational. Did you get this? Okay. Now similarly take the second operation, that is what? Subtraction. Now take two examples. Two irrational numbers. I will take two irrational numbers. What are they? Square root of 3. Square root of 3, one example, and one more example, irrational number, square root of 2. Now their difference. If we subtract them, what's the result? Result is square root of 3 minus root 2 itself. Therefore, what type of number is this? It is an irrational number. Irrational. Or in second case, I will take in this way. Take one irrational number, let it be root 3. Again take one more irrational number, root 3. Now subtract them. What happens? Root 3 minus root 3. It becomes what? Cancelled. So what type of number is this? 0 is an rational or irrational? Yes, it is a rational number. Therefore, we can conclude that if we subtract two irrational numbers, then the result may be irrational or it may be rational. Right? Take down. Now let us see one more mathematical operation, that is multiplication. Take two irrational numbers and multiply them. Now we will get the product as, let us see whether they are rational or irrational. Two examples. I will take two examples. Square root of 2 and one more irrational number, square root of 3. Now their product means multiplication. Root 2 into root 3 is equal to what? Square root of 2 3s are 6. Square root of 6 is what? What type of number is this? It is an irrational number. Irrational number. Similarly, take one more example. I will take root 5. What happens? Their product, root 5 into root 5 is equal to what? Root 5 square. Now what happens? Square root cancelled. So product is 5. Now again, what type of number is 5? 5 is a rational number, right? So what can we conclude now? If we multiply two irrational numbers, then the product may be irrational or it may be rational. Understand? Okay, now let us divide them. What happens if we divide two irrational numbers? Then what's about the quotient? Take two irrational numbers. You can take any irrational numbers. Now I will take irrational numbers, root 2 and one more example. Okay, divided by root 3. Okay, what is the result? Or quotient is equal to what? Root 2 divided by root 3 is equal to, I can write in this way also, root 2 divided by root 3 is equal to square root of 2 by 3. Now what type of number is this? Because it contains square root sign, therefore it is an irrational number. This is an irrational number. Right. Now take one more example. Square root of 2 divided by square root of 2. What happens? It's cancelled. So quotient is what? 1. What type of number is this? 1 is a rational number. Rational number. Therefore, what do we conclude now? If we divide any two irrational numbers, then the result or quotient is either irrational or it may be rational. Right? I hope all operations on real numbers, you got it, right?